Let us discuss the concept of a spring balance. I think all of you might have seen a spring balance somewhere in your surrounding. Spring balance is a piece of metal in which there is a spring along with some measurement marks, and on the two sides of a spring balance, one side it is connected to a fixed point and other side there is a hook on which we can hang any of the mass to measure. Like say if we put a mass M on the hook of the spring balance, due to the weight mg it will pull the spring balance hook in downward direction, due to which the spring is elongated and the pointer is displaced up to a point where it will be able to give a reading. And this pointer gives the reading of the weight of this block which is hanged on the hook of the spring balance. Now the spring balance has a general tendency to measure the tension in the string to which it is connected. Because when this mass is in equilibrium, we can simply state the tension in the string is equals to mg. And this tension will pull the spring of a spring balance in both the direction away from it. So because of which the pointer is displaced due to elongation of a spring, and it will give us a reading on the marks which are scribed on the spring balance. So we can simply state as a general concept, a spring balance always measures the tension in the string connected to it in units of kilogram force, just like that of a weighing machine. As we already discussed, 1 kilogram force is G Newton. Similarly here, if we wish to calculate the value of reading, so reading of a spring balance can directly be written as tension divided by G, and it is measured in kilograms if tension is measured in Newton. For a simple example, we can see if there is a table, on the two sides there are two pulleys, and say two blocks of equal masses 20 kg are hanging, and in between the table in the string to which the masses are connected, a spring balance is connected like this. If we wish to measure the reading of this spring balance, we can simply state due to the weight, due to both of these ways, 20 G will be the weight which will act in downward direction, and a tension is developed in the string. Now, as both the masses are equal, they must be at rest. So in this situation, we can state the tension in the string is equals to 20 G because the blocks are at rest. And as the spring balance is ideal, we can consider it to be massless. On both sides, it will be pulled with the same tension. And the reading of a spring balance, we can simply state in this equation, reading will be T divided by G. So T is 20 G, it will be 20 kg only. Sometimes students will develop a misconception that if two weights of 20 kg are hanging on the two sides of the spring balance, this 20 kg and this also 20 kg, in this situation the tension or the reading of the spring balance will become 40. But it will not be, because one mass will be acting just like a support, because as both are equal, they will not be moving, and the tension in the string will be equals to 20 G only. Like if we consider a similar example or a similar situation in which on one side there is a fixed support through which a string is connected, in which a spring balance is there and is connected to a pulley, and another block of mass 20 kg is hanging. In this situation, we can say if we find out the tension in the string, again it will be equal to 20 G because this is at rest. So the tension developed here and here will be equals to 20 G only. So in this situation also the reading will be equals to T by G, that is 20 kg. There is no difference in this and this situation, because here also this support, fixed support, will pull the string with the force of 20 G, or equal to that of tension, because this is again at rest. So in this situation, one block will be acting like a support and other is hanging, or we can consider this is hanging, this is acting like a support and this is hanging. So be careful in such situations. Whenever in a string there is a spring balance connected, the reading of a spring balance will always be the tension in the string in which it is connected, which is measured in units of kilogram force. Now to understand the concept of a spring balance, we take up an example. Here it is saying in the system shown in figure, we are required to find the reading of the spring balance, which is connected in a string of which is a part of this pulley block system. Here we can see there is one block of 80 kg and another block of 20 kg. We can say if this 80 kg block is coming down, this 20 kg will go up, and easily by using the constraint relations we can relate their accelerations. If say 80 kg is coming down with an acceleration a, we can directly state that this 20 kg is going up with an acceleration 3a. Because if it is coming down by x, it will pull this string by x, it will also pull this string by x, due to which this pulley will slide up by x, because of which it will pull this string by 2x. So this will be 2x and this will be x, by which this 80 kg is pulling this string. So we can say this 20 kg will slide up by a total distance of 3x. So its acceleration in upward direction will be thrice that of the acceleration of 80 kg block. Similarly, if we analyze the forces, here say in this string tension is T. So in this string tension must be equal to 2T, because we can treat this pulley as an ideal pulley. So net force acting on this pulley will be equal to 0. So this will also be 2T. We can say this spring balance is going to read this tension 2T, which is acting on this spring balance in units of kilogram force. So in this situation, if we wish to calculate the value of T, we have to write the equation of motion for the two blocks. Here we can see directly we write equation of motion of the two blocks. Like for 20 kg block, we can say it is experiencing its weight in downward direction, that is 20 g, and it is having a tensile force T in upward direction, and it is in all going up. So its equation can be written as T minus 20 g is equals to 20 into 3a. For this 80 g, we can say it is experiencing its weight 80 g in downward direction, and net upward force on this 80 kg block is 3t, 2t plus t. But in all it is coming down, so its equation of motion can be written as 80g minus 3t is equals to 80a. These are the two equations of motion we are having. To calculate the value of t, first we multiply equation 1 by 3 and we add the two equations, by which we can say the factor of t will get cancelled out. Will be having 80g minus 60g, it is 20g is equal to, we can see it was 60a, 60 into 3 it will become 180, 180 plus 80 it can be written as 260a. Now you can see the acceleration we are getting is 2g by 26, that is g by 13. If this is the acceleration of 80 kg block, that is a, from this equation 1, we can directly write the value of tension, which is equal to 20g plus 60a. If we put the value of a over here, we'll be getting 20g plus 60 into g by 13, which can be written as 320g by 30. That is equals to 3200 by 13 Newton. This is the value of T. But if we talk about the reading of a spring balance, reading of a spring balance will be equal to 2T upon G, because the tension in the string in which the spring balance is connected is 2T. So here it will give us 6400 divided by 13 multiplied by 10. So this will give us 640 by 13 kilogram. This will be the answer to this problem, which is the weight shown or the reading shown by the spring balance.